area of cross section can be determined if we know the length of object and if we know the mass of the object. That is why if you will go to the standard, it is written over there that the area of cross section can be found out by using this equation 0.00785 into L. Over here, today I will try to show you how this relationship is developed, and whatever the value of this area comes out after making this calculation, its unit is always n square. Now, I will give you the proof of this equation, that then it will become easy for you to understand. Let us suppose that I have this bar. I have drawn it in very bigger that you should be able to understand it very well. And its length is L. For the time being, I am assuming that it is 1 meter. And the diameter of this bar is taken as A, B. And the area of cross section is taken as A. From this area of cross section, this length and this bar is having the mass M. All I have written over here. Now from this, when the length and area is known, we can calculate the volume. This volume V is represented by area of cross section into length. Similarly, if we talk about this material, from the material point of view, we know that density of the material is equal to mass per unit volume. Here I will calculate the value of the volume is equal to mass M divided by the density. Now I will make the comparison of equation number 1 and also equation number 2. So here I can write down AL is equal to M divided by D. Now I have to find out the value of area A, which is the effective area of cross section. It would be equal to M over D into L. Here I would like to tell you one thing. Because we are studying the standard, accordingly this D is the density of steel and its value is very well known to us. It is equal to 7850 kilogram per meter cube. Clear? Here I want to tell you one thing. You see, this is 1 meter cube. 1 meter cube means 1 meter into 1 meter and into 1 meter. Now this 1 meter I want to convert into millimeter. How will I do it? You know, 1 meter is equal to 1000 millimeter. If I put this value in this expression, so I can write down that 1 meter cube is equal to 1000 multiplied by 1000 multiplied by 1000 meter cube, millimeter cube, mm cube. If I put this value over here, then this density of the steel will become 7850 over 1000 multiplied by 1000 and multiplied by 1000. So this is the value of the density. It is in kilogram per millimeter cube. Now this equation which I have derived over here, I will put in this equation. Let us suppose that this equation is represented by 3. As I put the value over here, it would be written as M over 7850 over 1000 1000 1000. Now, what will I deal to this value of L, which is in equation number 3? For your understanding, now I am assuming it unit length. This unit length means this length is taken as equal to 1000 millimeter. If I put this value over here, unit length. After making this, and you know, when this value is being divided by this value, we are going to get m over 0.00785. How? You see 1, 2, 3, 4, 5, 6. 1, 2, 3 and 4. I have to move, you see this is the decimal point at this point, and I have to move to the left hand side to the 6th digit. You see 1, 2, 3, 4, 5, 6. The 4 are already over here, then 2, 0 I have to introduce. So it is the very easiest mathematics like children. Now next I have written over L over here. The question arises why I have written L over here. If I will not write down the value of L over here, it means I am considering the unit length. All the time your length is not unit length. Your length can be less or more. This length can be less or this length can be more. When this length is not unit, it is other than the unit length, then we will have to put the value of L over here. So in this way, whatever the final equation our become, it is equal to m over 0.00785 into L. Whatever the value comes out to be over here, its unit will be mm square. So it means the final value comes out after calculation, it is mm square. Why mm square? Because the unit of area is mm square being considered. And I will give you one example over here. No issue, then you can understand it very well. Suppose, again I am taking L is equal to 1 meter. Now, I am taking mass of this material for 0.395 kilogram for 8 mm dia. This is the symbol of the dia. In bracket I can write down 8 mm. Steel having the dia 8 mm because this phi is the symbol for the dia. So this is my data, and as I will put this data in this equation, then I will try to find out what is the value of area of cross section. Here A 0.395 over 0.00785. As I will make the calculation over here, you just see that 0.395 divided by 0.00785, its value comes out to be 50.3. So this 50.3 mm square is the value of the area of cross section for a bar of unit length. Now I want to check that this my value is right or wrong. I will go to the standard. This is BS 4449. Here I will check 8 mm dia is having the area of cross section 50.3. So it means whatever the calculation has been done over here, it is right according to the standard. Now I will give you another example so that it will become easy for you to understand about all these parameters. Suppose I have the steel whose dia is equal to 10 mm, and mass of this steel is equal to 0.617. 0.617 per unit length. Here still I am considering it 1 unit length. When I will put these two values in the equation, area is equal to m over 0.00785 into L, then I will see what will be the answer. A is equal to 0.617 over 0.00785 into 1. Now let me make the calculation, then I will see the standard. 0.617 divided by 0.00785. What value comes out to be? 78.5 mm square. Now I compare this value with the value given in the standard. You see, this is the 10 mm. As I go to this 10 mm, the area of cross section also comes out to be 78.5. So here I can say that whatever this formula is being used in order to determine the effective cross sectional area, it is exactly giving the same result as our this formula A is equal to pi d square 4 is given. Now question arises, what is the difference between this formula and this formula? This formula is only depending upon the diameter. You see this one D, it is for the dia. But here we have any mass, we have any length, then we can find out the effective gross cross-sectional area. So this is the beauty of this standard. It is giving you that how you go through this one. Okay, when suppose you are not having any information about the dia, you are just taking the mass, you are just measuring the length, then you are finding out your area of cross-section or your gross area. But if the dia is known to you, then how will you find out the area of cross-section? Then you can use this equation. It was just preliminary introduction. Whatever our discussion is going on about the BS 449 standard for the steel, it was a part of that, because most of the engineers or the students who are in their universities, maybe they find some hardship. That's why I did this little effort that I should also contribute something for the students to improve their knowledge. Thank you for seeing this.